This is interesting. How do I record an ECS security best practice video when the actual service itself is not working from Amazon? Come on, Amazon! If you have just started working with container services from Amazon like ECS, ECS, Fargate, or maybe even ECR, you probably would have also read the recent container status report that came out, which spoke about over 70% of container images on the internet potentially have a lot of critical and high vulnerabilities. In case you don't know what critical and high are, it is pretty bad, and that's all you need to know. So in this video, we talk about what the security best practices are. And if you are someone who probably understands what ECS and the different kinds, you can use the timeline at the bottom to go straight to the security best practices, where we talk about Amazon as well as your own responsibility when trying to secure an ECS instance. However, if you have never heard of ECS, today is day one of you working on ECS, then stick around and we'll talk about what the business use case for ECS is and what you need to know about ECS in general. Then we go into security best practices. Let's start with the first obvious thing. I spoke about the container status report that came out, where 75% of the containers that were reported had high or critical vulnerabilities, which is, as I mentioned, is pretty bad. But they also reported that 50% of the containers had no limits defined. And if you're someone who probably works with operating systems like Linux, you probably understand the last one equally. 76% of the containers were running as root. As a Linux person, you would probably understand it's a pretty bad thing. The container services in AWS could be of two kinds. One could be in a virtual machine, which means you're hosting a container in an actual server. Or you could use a managed service from AWS, where they talk about Amazon ECS, Amazon EKS, Fargate. Now, because this is a bootcamp, you probably want to know, why would a business care about deploying ECS? The simple answer to this is a lot of organizations are going down the path of using containers as a way of deploying application. So the business use case we have is you have been tasked to deploy an application into an ECS service. I know there could be many versions that are called out. It could be Fargate, it could be EKS, but if you want me to make a video on this, it could be a separate video. Leave a comment at the bottom and I'll tell you the security best practice for Fargate, EKS as well. But in this video, we're going to talk about the ECS service. So that's our use case, but there's another use case over here. You need to be able to deploy these applications into a non-vulnerable image. And if these terms like image, ECR, ECS, they don't make sense, maybe the next couple of slides would. ECS as a service, the way it would work is you have an application and each of the application can be deployed into something called a container. Now, that's the task. You as a developer or someone who works on cloud regularly, you want to use ECS. ECS is almost like a front end or the door to access services where you can deploy containers in a way that's basically easily managed. You can use the Fargate option, which is the serverless option from AWS, or you can just use the virtual machine option, which is also available from AWS as well. Now, I'm going to focus primarily on the EC2 instance launch type, but I can make a separate video on the whole Fargate thing because it requires its own dedicated video. So let me know if you want me to make that as well. I'll leave that as a comment. The way this works is if I deploy an application into ECS, so for this video, if I have to deploy an application into ECS and I need to use the type EC2, I would need an agent running on the EC2 instance or the virtual machine that would be created by the ECS service, which could be an ECS container agent, which would talk to something called the ECR or Elastic Container Registry, which is where my images are. Now, in case any of those terms don't make sense, images is basically your operating system, like your Mac, your Windows, your Linux, and EC2 instance is a virtual machine like your laptop, which is maybe what you're watching this on. You can deploy images that you create yourself into an ECR as a repository or a location where you can store all your images. And at the same time, you can also link to something like a Docker Hub, which is a public site where you can have images downloaded. If you have been following along the bootcamp since the week one and you've gone through the entire playlist that we have on our Cloud Security Podcast YouTube channel, I will leave a link for that on the top. Essentially, that's the video where we spoke about how can you use container images and Docker Hub to make sure you have non-vulnerable images. But I just wanted to give you a hint. In case you have not seen the full playlist, you should definitely see the full playlist. I have been talking about launch types for ECS, but I haven't really called out what those launch types are specifically. This is a great diagram which explains what happens in a normal context as well as in an ECS context. So normally, if you have an EC2 instance where you want to deploy containers, you would have a auto-scaling group, which would help scale it up and down. You would also have something called a load balancer or an elastic load balancer in the front. In the ECS scenario, you would still have a load balance in the front, but what you're talking to is something called the ECS cluster. The ECS cluster can have a lot of EC2 instances that it itself is managing. So the cluster is managing the EC2 instances. Whereas in the previous scenario, with the diagram on the left, you're actually managing everything. You're deploying, you're scaling up, you're scaling down. But in an ECS scenario, you do create an ECS cluster and all of the services within that are managed by your ECS cluster. Now, there is another type of launch type called the Fargate. Fargate is the serverless container. Yeah, if you haven't heard that, another one for a video, definitely drop that as a comment if you want to make a video on the whole serverless container thing. This is obviously for a free bootcamp, and we're talking about free services, which is why I did not include Fargate. But happy to talk about that as well if you have to know more about the security best practices for Fargate. So Fargate is used to deploy serverless containers, and as you can see from the diagram, essentially you don't have control over anything. You don't see the EC2 instances, you just basically see tasks running, and Amazon manages your EC2 instances, the cluster, the service. You just define the task and IAM role, and off you go. There's a lot more to it obviously, but in this video we'll focus on the EC2 launch type. And another layer to understand this better is to understand the different responsibility. Now, as a security professional or someone who's interested in knowing the security responsibility, because you care about the safety of the application you're deploying on the containers, that's why you're watching this video, you want to understand the security risk that goes into it as well. The shared responsibility model from AWS specifically talks about between the EC2 launch type as well as the Fargate launch type, how much is managed by AWS and how much is not managed by AWS. In this option, because we're here for the free one, we're going to talk about the EC2. However, you would also notice that if I would have gone for the Fargate option, a lot of the services would just be covered. With the EC2 launch type, I have to manage the operating system, the storing, the logging, the container runtime, also what application I'll be running, and if anything else I need to do as well. That's where maybe you might consider going down the path of building a serverless container. But there are some challenges with serverless containers. So it's worthwhile knowing, why would someone choose to go for an EC2 launch type instead of a Fargate or a serverless launch type? For example, if you're using Fargate, you have no access to the infrastructure. And if you're required by compliance or legal or privacy reasons that you should have access to infrastructure, or you should be able to run real-time agents on your machine, then Fargate may not always be the best option because you have no access, because Amazon manages that for you. There is no file or network monitoring. There are only ephemeral resources, which also means that you don't have access to these resources after they've been deployed, which makes the job of troubleshooting or forensic really hard. Even in the scenarios, container best practices, not the Docker container practices that we spoke about in the video, I'll leave a link over here. The container security best practices still apply, where it should not have too many privileges like root. It should also have only read-only file systems. It should not run unverified images as well. So this is still a lot more that goes into Fargate. Fortunately, because we're talking about EC2, let's do a quick walkthrough and let's talk about how you would deploy ECS. Okay, this is our console. Now, before we go down the path of using ECS, let's start with something basic. Because you're building a machine over here with containers, you probably want images. So the first place you would go for is ECR, or Elastic Container Registry. I obviously already have a registry over here which I can work with. However, this is something for you to understand. You can create a repository, you can make it public or private. Now, this is security best practice number one. If you know your image needs to be something owned by the company, you probably want to go for the private option. Public is something you want anyone on the internet to be able to access it. So you probably want to just be mindful of that. I'm just going to be private. I'm going to call it Cloud Security Bootcamp because that's what this is. And I can also have the tag immutability on as well, which basically means that every time a new image is pushed out, it consistently manages the same tags, and I'm not created with multiple tags every time I push a new image, which probably brings the question, where am I pushing the image to? The repository is the place you're pushing the image to. So Docker Hub is an example of a public container registry, also known as a repository in the context of AWS. In the context of AWS, the repository is the same as Docker Hub. Does that make sense? Docker Hub is public, ECR can be public or private depending on how you want it. So in this scenario, we're keeping it private because we know we're going to use it for production and for our bootcamp. The other thing that I love is definitely switch on scan on push. This is another good practice because what this would do is every time someone would push a new image into this repository, it would be scanned. Now, the kind of scan is an interesting one, which we'll come to later, but definitely keep going. You should also use encryption on the images. That is just to default. I don't want to customize this right now. I'm just going to use the default. Now, this is me defining the lifecycle of what happens in this registry. I'm going to click on the repository create. It has created a repository for me. And as you would see, I have the continuous scan. I've also got my immutability enabled, and this is literally just pushed out. Now, there should not be any image in it. So if I click on it, there is nothing in there at the moment because I don't have another one. So what I can do is I can click on this view push command and I can see, oh, this is how I would use a set of commands to go. I want to build an image. So what I'm going to do is I'm going to open my command prompt. So for us to run these commands, I need to be able to log into my CLI. So the first thing I want to do is I want to open my CLI. Now I obviously have AWS already configured. So if I can do AWS -- version, if I can type that in, Sweet. So I've got AWS already installed. This is the AWS CLI. If you want to know how to install AWS CLI, definitely let me know. I'll create a video for it. So I'm going to assume you've already done this and you're looking at the same screen as I am with the black and white screen terminal. I would go back to the Windows and I can see, oh, okay, so the first command over here is for me to do all of that. For people who don't know what Linux is, essentially what it's done is it's basically saying, hey, AWS ECR login password in the region of US East 1. I want you to run this command, which is the Docker login username password, and yeah, get all that information for me. So I'm also going to add, because I am using an IAM user, which is another good practice. I'm just going to go profile, because I have a profile here on this machine, and go blah, and that should do its magic. Oh, there you go, login succeeded. So it's a good thing. So my username password is set up correctly. I have the AWS CLI select set up correctly. Now I move on to the next command, which is I'm just going to build the actual image. So that's my image command to be built. I'm going to paste that in. Okay, so now we know it's been finished. And if you want, you can just do a Docker scan to run all your sync tests, because we've done this in the Docker video before. So definitely check out that video out if you haven't already. All right, so next command I'm just going to do is I'm going to tag this and attach to my registry. Probably easier if I just show you it this way. Now I have tagged this resource. Now I am going to copy the last command. I'm going to push this out to my ECR. Now, if you remember, we did have the scan on push command ready. So moment this is pushed at the moment, if I go back to my registry, yep, if I close this, I don't have anything, but it should start coming up shortly. Okay, we know now our image is created and it's definitely been pushed onto the repository, which is our ECR. So if I go back into this, if I go here and if I refresh, and voila. Oh, look at that. It's already done the scan for me, because as I told you, there's a push scan ready. From a foundational perspective, I have the operating system. I have the project, which is going to be the case, but I don't really have a place to put this in. So the next step over here is to go to ECS. So remember, the first step, you have to create the ECR, which is a repository, then the image, and now I'm ready to build the infrastructure where I'll be deploying the application. So you've probably seen this before as well. There's a Fargate option, EC2 options, as well as the ECS Anywhere option. For people who don't know what ECS Anywhere is, there's an EKS Anywhere as well. But the idea behind this is that you should be able to deploy containers and Kubernetes on any infrastructure outside of AWS as well, which is the Anywhere service. Now, both the Fargate option as well as the ECS Anywhere option are a paid service. So is the EC2 service, but essentially you're just paying for the EC2s that you're running, so you can kind of control it. With Fargate, it's a bit tricky, so I'm just going to stick to the ECS with the EC2 one in this context. So I'm going to go cluster. I'm going to co-start this a cluster. So as I showed my diagram, essentially the ECS is a cluster that you're creating. I'm just going to call this my Cloud Bootcamp. And I've got my VPC, I've got my subnets, all of them. I've got my namespace, and I'm going to group them together. I'm just going to say I want a EC2 instance. I just want a minimum of 1 and a maximum of 1. So this is how you would manage your cost as well. The other thing I can also do is I can say I'm just after the Amazon Linux, and I'm also after the smallest image that I can find. So I'm just going to use A1 if it allows me to do that. But this is an interesting one. I don't want the ability to be able to log in into it, so I'm not going to create any of this. I'm also not going to do any of that as well. So tagging is important, so I'm just going to name this as my Cloud Bootcamp, if I can spell correctly. All right, so the cluster will take a couple of seconds to create. This is interesting when, well, it's an amazing video when the actual service does not really work. So how are we going to work around this? I'm going to choose an image which is just probably the smallest one I can go for, maybe T2 Micro, T2 Nano. Let's go for T2 Micro. This is one of the free tier ones. I'm going to have minimum as 1, maximum as 2. So that should just be sufficing me. I'll leave a tag. I'll add a tag. So I'm just going to call it name. In this case, I'm going to call it dev cluster, because I'll just literally renamed everything dev cluster. So I'm just going to call it dev cluster. And it's going to take a couple of seconds to create. Let's quickly come back into the video after this is created. Now, while that's being created, I'm just going to create a new task definition where I'm just going to call this a dev cluster, because this is a dev instance. I'm going to call this thing as, because that was Ubuntu, I'm just going to call it Ubuntu here just for the name ease. And that is my repository URL. Now, where would I get the repository URL from? You got that right. This is why you had to create that before. So I'm just going to go into my ECR, which is my registry. And I already have a repository that I have created earlier. And I have also got the image as well. So that's the digest. All right, that's my URL. I just copied the image and I want to come back in here. Sweet. That's also the format. And the container port is 80. And I'm not going to add the entire environment variables. I'm not going to add any of these Docker config. I'm just going to keep it super simple for now. So yeah, I've got dev cluster, blah, blah. That's my next. I don't want it to be app environment is EC2. I don't want it to be serverless. Yep, one CPU task role. If I wish to, I can give the task itself an INO, which is probably a good practice to have. Execution role and task role are separate. As you can read over here, task execution role is more for the container agent that will be running on your EC2, whereas task role is for the API the containers will be calling. So definitely pick the least privilege access IAM role thing over here. But this example also highlights the fact that you can have two sets of IAM roles defined over there. Now, something I definitely want to do is use log collection. I have the option of CloudWatch. I can do all of these things just to save money if I want to, or go super technical with the logs, but I'm going to keep it simple. I'm going to call Amazon CloudWatch. Those are the log groups that are available. This is how the values would appear. Now, you need this from a logging perspective because remember, I did not give it the access to SSH. I don't want it to have the ability to SSH into it. So I'm just going to make sure that I am not in a stage where I can't see what's going on in the container in case this fails. So now I have the log collection. I'm going to go next. Oops, I forgot to give the tag. I need to give the tag. It's always a good practice to give tags. A tag, name, again, dev cluster. One only realizes how hard is it to type while still having the mic over there in your one hand. Cool. I think I like everything I have got over here. Create. All right, so at this point in time, I have my cluster created. I also have my task definition. So this is looking really nice. And as I had shown in the diagram, ECS cluster is where all of this magic happens. So that's what we're going to work on. Now, I do have a cluster, but there's nothing really going on here. So how about we run a few tasks? Yes, this is where the task definition comes in. So I come here, I say I want to run a new task. Now, I want this to be a launch type, where I want the launch type to be EC2. Now, I can use a capacity provider or I can use a launch type. As this video is specifically about launch type, I'm just going to use a launch type. I have the Fargate option, external option. I'm going to use EC2. I'm going to say task, and I'm going to use my task definition. And I don't want to do anything else apart from that. I don't want to do any kind of changes to networking at this point in time. Nope, default security group. I don't want to do any container overrides. And oh yeah, task definition can propagate itself. That's good enough. Okay, so now since we have created an application, now let's go into the other part, which is the second business use case. We want to make sure that the image that we're running is a secure one. Now, in my demo, you would have seen that I was just scanning every time an image is pushed. Now, you may already have a set of images that are not pushed, and you need to figure out a different way of doing this. So let's talk about that. If you go to ECR, this is the image that we have from earlier. And if I go into my bootcamp, which is the repository name, I see my container. Now, this is obviously automatically done the scan because I had it set to continuous. So the original repository that I downloaded from Ubuntu did not have any vulnerabilities, so I had to upload another image. Let me just do that quickly. Okay, so this is uploaded, and I'm going to quickly come over here. I should see my image. Oh, that's my image over there. This is my new repository because my other repository did not have anything, so I'm back to just on my other repository. So as I mentioned, I had to create a second repository because my original repository did not have any vulnerabilities, but this one as well has an automatic scan on it. Now I've got the Docker getting started, which is the default image which you find in most servers. And if I see findings, oh, looks like I have 1 critical and 13 high. Now I obviously want to remove these vulnerabilities and probably get rid of them. What you would also find is this is linked to the inspector thing that I called out earlier. If I just go to inspector, you would realize that this should pick that up. It has picked up my ECR container, has one critical vulnerability. So these are all linked together because essentially in the background, as part of the continuous scan, so if I come back onto the repository, if it says continuous over here, that essentially means it is the Amazon inspector, which funny enough is using Snyk in the background for its threat intelligence. If you don't remember what Snyk was, it was in our cloud security bootcamp. And if I come over here, I called out all the repositories. You can use our GitHub link, which will be in security best practice, but I'm also showing you Amazon Inspector. Claire is what runs in the free service in the background. Snyk is what is being used as threat and integrate with your GitHub account, which is already hopefully logged in because we're all working GitHub, right? And I don't want the extension. If you are using other than ACR, other images from Docker or any of the services publicly, or even ECR themselves, you can use Snyk to identify them and have all of them in one central place. But you can also use all this information in the inspector. So I'll go back into inspector again. And once I have resolved all the vulnerabilities which are listed in inspector, or I guess ECR, whichever way you see it, if I resolve this particular vulnerability, which would simply be a matter of me creating the image with the latest patch, and that should solve that problem. Right. That's pretty much what I want to cover from an ECR image security perspective as well. Let's really talk about how does the whole enhanced scanning work. Now, as I was trying to show you, because I had the scan on push enabled, every time I was putting an image onto ECR, it was running a scan with inspector, and it basically circles back and go, oh wait, there's a vulnerability or there's not a vulnerability. That's how the continuous scanning works. But if you want to know more about real-time container monitoring, which is essentially what is running in the ECS container or container service right now, which may be vulnerable, definitely let me know in the comments and I'll create a video for you for that as well. Let's walk through the security best practices. Now, because this is a semi-managed service, there are components which are managed by Amazon and there are components that are managed by you yourself as a client. The first thing you would look at as a security best practice from an Amazon perspective is the control plane. That is the AWS console. Who has access to it? Who can create ECS, ECR? Who can manage images? How would you be able to delete images if you could delete images? All that is part of the cloud control plane. The configuration of should be the top priority from a security best practice to have it in a way that it is provided by a role-based access. Now, VPC endpoint is another great one to have where you can either use, if you have used the launch type of EC2, where you have security groups attached to the cluster itself, you should be able to use that to limit access to certain resources or use the security group itself. However, you can also use VPC endpoints as a way to limit it to a private link itself, especially if you have on-premise connections in there as well. As you would have seen in the demo that we just did before, you would have seen that we have something called the scan on push enabled on the images that we are uploading to the repository, which means every time it uploads, it would use either the free version, which is the Claire, which is called basic, or the enhanced version, which is using basically Amazon Inspector as well as the Snyk in the background. Again, definitely check out the Docker security best practice so you're able to at least see how to see this in action, especially if you're working on containers that are not on ECR but maybe on Docker Hub. You also want to make sure that the repository that you create where you are storing your images, it is not public if it doesn't need to be, especially if you work for a production organization. I don't imagine they would ever make it public or allow you to make it public, so definitely want to be sure that you are allowed to do this as well. Preventative measure could also be to use your organization SCP in a way to create restrictions for managing deletion tasks. Like I'll take you to the Cloud Security Bootcamp website, which again, if you go to the GitHub, we have the repository linked over here, which is AWS SCP best practice. And within this, you will find one for ECS capability and one for ECR capability. Definitely check those repositories out as they'll give you the SCP examples for what you can enable on your organization. Definitely have your CloudTrail because that is the auditability of your account. And if anyone is performing actions that you don't want to be actioned, you should be able to use CloudTrail to alert yourself and to remove them as well. Now, at the moment, GuardDuty does not support ECS. It does support EKS at the moment, which is not the topic. So we're able to use config rules to be able to enable more configuration management onto the ECS from an AWS perspective. Talking about application side, which is also your responsibility, you obviously want to make sure the application you're uploading is safe to be uploaded for your customers, but there are certain basic rules that you probably want to apply for. Like, for example, the container security best practice, like limiting the root privileges, limiting resources that are being utilized, having read-only access, not having your SSH, using CloudWatch to manage logs instead of letting people log in, making sure, because we're talking about ECS with EC2, Make sure you're running the most recent version of the ECS agent daemon on your EC2 instance. Make sure your access role, specifically the task execution role as well as the task IAM role, they are configured in a way that they limit access only for what it should be doing. You can also, however, use cluster, services, and tasks to limit roles as well. Last but not least, because we've had the whole business case around the use of only safe images, definitely make sure the images you are using are safe and that you don't store any secrets or password in task definitions or in any of the containers as well. Try and use Secret Manager. This always works out. If you want me to make a video on Secret Manager, definitely let me know as well. All right, now you're ready to go ahead and start creating applications and deploying them in container services. Let me know if you have any more questions. We talk about cloud security all day, every day on this channel. And if you have a request for a particular video walkthrough that you would like us to do, definitely leave that as a comment. I would see you in the next class. Peace.